All right, so we've got codominance and incomplete dominance today. We're going to start off with codominant problems and then we'll work our way into incomplete ones. This is a paper for you guys to be doing on your own. I'm going to go through a couple just as examples, but I'm not going to do every single one of them. So I'm going to have you guys do a few. Since you are doing it online, you don't have to write out your Punnett squares right now. If you want to, you can take a picture of your work and send it to me that way. Or you can just answer the questions as you're going through it, and that way I'll know that you did the squares correctly. So we're starting off with just some definitions. Explain the difference between incomplete and codominance. So incomplete dominance. Very simply stated, it's a blending of traits. Codominance both show. There's no blending. They are each on their own little playing field there. Don't forget to make a key for each problem. So in some chickens, the gene for feather color is controlled by codominance. The allele for black is B, the allele for white is W. Heterozygous phenotype is known as erminite, which is a black and white spotted chicken. What is the genotype for black chickens? So here's our key. It's going to be two B's. Genotype for white chickens is two W's. Erminite chickens is going to be VW. If two erminite chickens were crossed, what is the probability that they would have a black chicken and a white chicken? Let me move this down a little bit. Why is it not going down? There we go. Okay. So I'm crossing erminites. So that's going to be the heterozygous form, BW. You always want to have your letters alphabetically if you can. The percentage of them having a black chick, so you got to have two B's for a black chick. And there's just one block that has that, so that would be a 25% chance. The white chick is going to be the two W's, so that's also a 25% chance. The genotypic ratio, we're just going to go alphabetically here. So we have one that's BB, two that are both, and one that is WW. My phenotypic ratio is going to go black, erminite, white. A black chicken and a white chicken are crossed. What's the probability that they will have erminite chickens? It's looking like 100%. The genotypic ratio. I have no 2Bs, I have 4 BWs, no WW. No blacks, 4 erminites, no whites. I'm going to leave you guys to do those two problems yourselves with the codominance. And I'm going to skip on down to some incomplete dominance problems. So you may want to pause the video while you do those last two problems. So making a key here. In snapdragons, remember incomplete dominance is where we blend the traits in the heterozygous form. So the two alleles are red, which is capital, and white, which is lowercase. The heterozygous genotype is pink. So the phenotype of a plant with the genotype RR is going to be a red color. If it's two little ones, it's going to be a white color. And if it's one of each, it will be a pink color. A pink flowered plant is crossed with a white flowered plant. What is the probability of producing a pink flowered plant? So my parents, my pink plant is going to be one of each. My white plant is going to be two little ones. There's my pink flower, there's my white flower. What is the probability of producing a pink flowered plant? It's about 50%. So now I got to switch back to my genotypic ratio here. We're going with dominant, hetero, and recessive. So I don't have any that are homodominant. I have 2 heteros and 2 homorecessive. For a phenotypic ratio, I don't have any that are going to be red. I have 2 that are pink and 2 that are white. So my ratios are matching again. The only time your ratios don't match is whenever you do the complete dominance ones, which was the first type of Punnett score that we did. What type of cross will produce the most pink flowered plants? So we want all of our plants to be pink. So that means that I want to have this heterozygous genotype filling up my box. So if I'm pulling a little r up here, that means that, so since this letter is gone for both of those boxes, over here has to be a capital R. So I'm getting rid of the capital R here. Which means that I would be pulling up a lowercase r here, and I'd be pulling an uppercase r over there. So my parents would have to be a red plant and a white plant. My genotypic ratio is going to be 0 to 4 to 0. And my phenotypic ratio will also be 0 to 4 to 0. And I'm going to leave those 2 for you guys to do on your own. There is a bonus question which you can do if you want to. It is up to you. It won't hurt you if you get it wrong. It can only help you. All right, so you guys have 4 problems to do all by yourself. Good luck, guys.